Welcome to Module 4. In Module 3, we built mastery over how you communicate with AI systems, the anatomy of a prompt, the architecture of reliability, and the cognitive paradigms that unlock multi-step reasoning. That body of knowledge made you significantly more precise and effective in directing individual AI interactions. But individual interactions have a ceiling. The most consequential shift happening in enterprise AI right now isn't about better prompts. It's about a fundamentally different kind of system, one that doesn't wait to be asked a question, but autonomously pursues goals, uses tools, coordinates across systems, and executes complex workflows over time. This is Agentic AI, and it represents a qualitative leap from AI as a conversational interface to AI as an operational actor. In this module, we're going to understand what agentic systems actually are under the hood, how enterprise-grade architectures are built to deploy them safely and at scale, and where the boundaries of current capability lie. By the end of Module 4, you'll have the mental model to evaluate, design, and govern agentic AI deployments in real organizational contexts. Let's start with the blueprint.
Before we go any further, let's be precise about what an AI agent actually is, because the term gets used loosely in ways that obscure what makes agentic systems genuinely different. An AI agent is a software entity that autonomously perceives its environment, reasons about goals, makes decisions, and takes concrete actions using tools and APIs, while maintaining state over time. Let's unpack each part of that definition, because every word is carrying weight. Autonomously, the agent operates without requiring a human to guide every step. You give it a goal, not a sequence of instructions. Perceives its environment. The agent isn't just reading a single message. It's processing inputs from multiple sources, user requests, system states, data feeds, API responses, error logs. Reasons about goals. The agent maintains an objective and plans the sequence of actions needed to achieve it. It doesn't just respond, it strategizes. Makes decisions when it encounters ambiguity, constraints, or unexpected situations. The agent evaluates options and selects a path. Takes concrete actions using tools and APIs. This is the key differentiator from a chatbot. The agent doesn't just produce text. It calls functions. It reads and writes data. It triggers workflows. It modifies the state of external systems. Maintains state over time. The agent remembers what it has done, what it has learned, and what still needs to happen. It persists across multiple steps toward a goal. That last part is what makes agents categorically different from a conversational LLM. A chatbot answers questions. An agent accomplishes missions.
To understand why agentic systems represent such a significant shift, let's draw the contrast between a standard LLM application and a true agentic system, because organizations often build the former while thinking they're building the latter. A standard LLM application is fundamentally reactive. A user submits a prompt, the model generates a response, the conversation ends, or another prompt begins. The model has no persistent goal, no memory of prior sessions by default, no ability to take actions in the world, and no mechanism for self-directing toward an outcome. It answers the question in front of it, full stop. An agentic system is fundamentally proactive. It owns a KPI or a goal state, not just a current query. It coordinates with external systems, databases, APIs, services as a first-class behavior. It handles ambiguity with minimal human intervention by reasoning about what additional information or actions are needed. And it persists toward a goal across multiple steps, often over multiple minutes or hours. Consider the difference in a customer service context. A standard LLM application tells you how to initiate a return. An agentic system receives a return request, looks up the order, checks the return policy, verifies the customer's eligibility, initiates the return in the order management system, sends the customer a confirmation, schedules the pickup, and updates the CRM, all without a human touching a keyboard. Same underlying technology, completely different system architecture, completely different business impact. The shift from LLM application to agentic system is the shift from AI as a reference tool to AI as a capable member of your operational team.
To operate effectively in the world, an agent needs 4 core capabilities. Think of these as the pillars that hold up everything an agent does. The first pillar is perception. Perception is the agent's ability to observe and understand its environment, not just to receive a single text message, but to actively monitor and interpret inputs from a diverse range of sources, and to understand what those inputs mean in context. What does an agent perceive? User messages and requests, obviously, but also system alerts that signal something has gone wrong in an application or infrastructure, real-time data feeds, stock prices, sensor readings, order status updates, log files, and performance metrics, the outputs of other systems and agents it's coordinating with. Even the passage of time. Certain agents act on schedules, not just triggers. The sophistication of perception goes beyond just receiving these inputs. A capable agent needs to understand urgency, relevance, and context. When a customer support agent receives a new ticket, it doesn't just read the text, it perceives the customer's emotional tone, the severity of the issue, the customer's history, and the appropriate escalation path. It understands what it's seeing, not just that it's seeing something. This perceptual layer is what allows an agent to be situationally aware rather than just informationally aware. And situational awareness is the foundation of good decision-making. An agent that perceives its environment poorly will plan poorly and act poorly, regardless of how sophisticated its reasoning engine is. Perception quality is therefore one of the first things to evaluate when designing or assessing an agentic system. What can it see? What can it not see? What signals is it missing? The second core capability is reasoning and planning, and this is where the LLM at the heart of the agent does its most important work. Reasoning is the process of taking an observed situation and a goal and figuring out what needs to happen to close the gap between the two. For simple tasks, this might be straightforward. The customer wants to reset their password. I need to call the password reset API. For complex tasks, it requires genuine multi-step deliberation. Planning is the output of reasoning, a structured sequence of actions, decisions, and contingencies that the agent will execute to achieve its goal. A good plan anticipates obstacles, identifies which tools or resources are needed at each step, and defines how to evaluate whether each step succeeded before proceeding to the next. The agent doesn't just guess and act. It generates a reasoning trace, an explicit internal chain of thought that spells out the logic behind its decisions. This is directly related to the chain of thought prompting techniques we covered in the last module. In agentic context, step-by-step reasoning isn't just a prompting technique, it's an architectural component. The reasoning trace is often logged, monitored, and evaluated as part of the agent's governance stack. This matters for explainability. In regulated industries, you often need to answer the question, why did the agent do that? A system with explicit reasoning traces can answer that question. A system that jumps from input to action without showing its work cannot. Reasoning and planning also determine how gracefully an agent handles failure. When a tool call returns an error, or when a plan step produces an unexpected result, the quality of the agent's reasoning determines whether it recovers intelligently or fails catastrophically. The third core capability is where the agent crosses from thinking to doing, action and tool use. This is the capability that most cleanly separates an agent from a chatbot. A chatbot produces text. An agent takes actions that change the state of real systems, and it does this through tools, programmatic interfaces that the agent can invoke to interact with the world outside its context window. What kinds of tools can an agent use? The list is essentially unbounded. Database tools, query, insert, update, delete records in structured data stores. API tools, call external services, retrieve weather data, look up customer records, check inventory levels. Communication tools, send emails, post Slack messages, create calendar invites, generate tickets. Code execution tools, write and run Python or SQL, process files, perform computations. Browser tools, navigate web pages,
fill forms, extract information. Infrastructure tools, trigger deployments, scale services, manage configuration. Consider a real example. A finance operations agent processing an invoice might call a lookup tool to retrieve vendor payment terms, call a validation tool to check that the invoice amounts match the purchase order, call an approval routing tool to determine who needs to sign off based on dollar amount and category, call a payment scheduling tool to queue the disbursement, and call a notification tool to alert the relevant parties. Each of those tool calls is a discrete action with a discrete outcome. The agent sequences them, handles errors between them, and adapts its plan based on the results. That sequence of tool calls, orchestrated by the agent's reasoning engine, is what makes a workflow automation possible, without a human writing the logic for every branch and edge case. Tool use is power, and like all power and production systems, it requires guardrails. We'll get to that shortly.
The fourth and final core capability is memory and state, the capability that allows an agent to operate not just for a single task, but across time. Memory in agentic systems has two distinct layers, and understanding the difference is important for both capability design and system architecture. The first layer is short-term working memory. This is the agent's in-context state. Everything it's currently tracking within an active session or task execution. The current user request, the steps it has completed, the tool call results it's received, the intermediate conclusions it's reached. This working memory lives in the context window and is what the agent actively reasons over in the current moment. The second layer is long-term episodic memory. This is persistent storage, information that survives beyond a single session and can be retrieved in future interactions. User preferences, past interaction outcomes, lessons learned from previous task executions, organizational knowledge the agent has accumulated. This layer is typically implemented through vector databases and retrieval mechanisms, essentially the same RAG infrastructure we covered in Module 2, now applied not just to documents, but to the agent's own accumulated experience. Together, these two memory layers give the agent temporal continuity. Without them, every interaction starts from zero. The agent has no context for who the user is, what's been tried before, or what institutional knowledge is relevant. With them, the agent can build a progressively richer operational picture over time. This is what enables agents to improve with use, not through weight updates that would require retraining, but through experience retrieval. The agent learns to apply lessons from past tasks to new ones by storing and accessing its own operational history. That's a meaningful form of organizational learning embedded directly into the system architecture.
Now that we understand the four core capabilities of an individual agent, let's zoom out to the enterprise architecture. Because in production deployments, you're not building one agent, you're building a system of agents. And the architecture of that system determines whether you get a powerful operational platform or an expensive failure. Enterprise agentic architecture is organized in 5 layers. Let's start with the top 2, the layers closest to the humans using the system. The experience layer is where users interact with the agentic system. This isn't a special AI interface. It's where your users already work. Slack, Microsoft Teams, email, internal portals, customer-facing chatbots, mobile apps. The agents are embedded in existing workflows rather than requiring users to learn a new interface. This is a critical design principle. Successful enterprise AI deployments meet users where they are, not where the technology prefers them to be. Beneath that is the agentic layer, which is the operational core of the system. This is where individual agents live, where they're orchestrated and coordinated, and where complex multi-agent workflows are managed. In this layer, you'll find orchestrators, agents that plan and delegate work to specialized sub-agents, and sub-agents that execute specific, bounded tasks within their domain of competence. The orchestration mechanism in this layer is critical. It determines how tasks are routed, how handoffs between agents occur, how failures are escalated, and how the overall workflow maintains coherence even when individual agent actions produce unexpected results. This layer is where the architectural complexity of multi-agent systems lives.
The next 2 layers in the enterprise stack are the foundation that the agentic layer is built on. Without these layers functioning well, even a perfectly designed agent architecture will fail. The third layer is the AI and machine learning layer. This is where the language models live, the reasoning engines that power each agent's planning, decision-making, and language understanding. But this layer isn't just a single frontier LLM. It's a portfolio of models, selected and deployed based on the specific requirements of different tasks. Large frontier models for complex reasoning and planning, smaller, faster, cheaper models for high-volume routine tasks where reasoning depth is less important. Specialized models for domain-specific functions. A fine-tuned model for contract analysis. A specialized model for code generation. The ML layer manages this portfolio and routes agent reasoning requests to the appropriate model based on cost, speed, and capability requirements. The fourth layer is the data, knowledge, and memory layer, and this is where your organization's actual intelligence lives. This layer contains the vector databases that power RAG retrieval, the structured databases your agents query for real-time business data, the document repositories, contracts, policies, procedures, technical documentation that ground agent reasoning in organizational context, the integration connectors that link these data sources to the agents that need them. This layer is often the most underestimated in initial agentic deployments. Organizations focus on the AI model and the agent logic and discover too late that their data layer is fragmented, inconsistently formatted, or missing the metadata needed for effective retrieval. The quality of this layer directly bounds the quality of agent outputs. Garbage in, garbage out, at enterprise scale.
The fifth layer sits across the entire architecture, not under any single layer, but alongside all of them. This is the governance and observability layer, and in a production enterprise deployment, it may be the most critical layer of all. Here's why. An agent that takes actions in the world can cause real harm. It can delete records, send emails, initiate financial transactions, modify configurations, and trigger workflows, all autonomously, all at machine speed. Without governance, one misconfigured prompt, one unexpected edge case, one failure in a tool integration can cascade into serious operational damage before any human notices. Governance addresses this through several mechanisms. Least privilege access control. Each agent is granted only the permissions it needs for its specific task. An agent that processes invoices has no business having write access to the user identity store. Access scoping is a fundamental safety control. Policy enforcement. Business rules are encoded as hard constraints on agent behavior. A refund agent can approve returns up to a specified dollar threshold. Above that, it escalates to a human reviewer. These aren't just instructions in the prompt, they're enforced at the infrastructure level, so a jailbreak attempt or a confused reasoning trace cannot override them. Audit trails. Every action the agent takes, every tool call it makes, every decision it reaches is logged with sufficient detail to reconstruct exactly what happened and why. This is non-negotiable in regulated industries and essential for debugging in any industry. Observability. Real-time monitoring of agent performance. Hallucination rates, task success rates, latency, tool call failure rates, human escalation rates. These metrics tell you whether your agents are functioning as designed and alert you when they're not. Governance is not an afterthought. Build it first, deploy it comprehensively. It's what separates a production-grade agentic system from an interesting prototype.
Now we get to deployment strategy. And this is where organizations frequently make a costly mistake. They see the vision of fully autonomous multi-agent systems and try to build Tier 3 from day one. The result is almost always a failure that sets back the organization's AI adoption by months or years. The right approach is a 3-tier maturity model that builds capability, trust, and organizational confidence progressively. Tier 1 is intelligent assistance. In this tier, agents operate as read-only copilots. They perceive the environment, reason about the situation, and generate recommendations, suggestions, and analysis, but they do not take actions. A human reviews the agent's output and executes the final steps. Examples of Tier 1 deployments: a customer service copilot that reads an incoming ticket, retrieves relevant knowledge base articles, drafts a suggested response, and presents it to the human agent for review and send. A sales intelligence assistant that researches a prospect account, synthesizes key facts, and surfaces talking points before a call. An IT support assistant that diagnoses a system issue and recommends remediation steps, which a human engineer then implements. The value of Tier 1 is real and substantial.
It reduces the cognitive load on human workers, improves the quality and consistency of their outputs, accelerates their throughput, and captures the value of AI assistance without exposing the organization to the risks of autonomous action. But crucially, Tier 1 is also where you earn the data and the organizational trust to move to Tier 2. You observe the agent's reasoning quality. You identify where it succeeds and where it struggles. You calibrate your governance policies, and you demonstrate to stakeholders that this technology improves outcomes before you give it the ability to act.
Once your Tier 1 agents have demonstrated consistent, reliable reasoning quality, and once your governance infrastructure is validated and trusted, you earn the right to move to Tier 2, guided automation. In Tier 2, domain-specific agents take constrained actions, but within carefully defined boundaries. The agent no longer just recommends, it executes. But it executes within a policy envelope that defines what it can and cannot do autonomously, and it routes to human approval for actions that exceed that envelope. Let's look at concrete examples. An IT operations agent receives an automated alert about a disk space threshold being breached. It diagnoses the issue, identifies low-priority log files that can be safely archived, and performs the archival automatically. That's within its autonomous authority. When it identifies that the root cause is a storage configuration that requires reallocation, it creates a ticket and routes to a human engineer. That exceeds its autonomous authority. A finance operations agent processes standard invoices end-to-end, validates the invoice against the PO, routes for appropriate approval, schedules payment, and updates the ledger, autonomously for invoices under a defined dollar threshold. For large invoices or unusual terms, it escalates with a full analysis package for human review. The key design principle at Tier 2 is that approval gates are not failures, they are features. They're the mechanism by which the system maintains human oversight on high-risk decisions while automating high-volume routine ones. The agent's job is to make the human's decision as easy and informed as possible, then execute immediately upon approval. Tier 2 is where you start seeing significant operational ROI, reduced cycle times, lower error rates, and measurable cost savings. It's also where your governance layer gets its real test, because now the agent is touching real systems with real consequences.
Tier 3 is the fully realized vision of Agentic AI, the autonomous network. This is where multiple specialized agents coordinate with each other across complex, multi-step workflows, spanning systems, departments, and organizational boundaries, with minimal human involvement in routine operations. The scale of what becomes possible at Tier 3 is genuinely transformative. Consider a quote-to-cash workflow. A customer requests a complex enterprise quote. A research agent pulls together the customer's account history and current contract terms. A pricing agent calculates the optimal quote based on margin targets and competitive positioning. A contract agent generates the customized agreement. A CRM agent updates the opportunity status. An approval routing agent manages the internal review process. Once signed, a provisioning agent initiates service delivery, and a billing agent configures the payment schedule. A monitoring agent tracks delivery milestones and surfaces exceptions. What would have required coordination across 5 or 6 departments, dozens of human touchpoints, and days or weeks of elapsed time, automated, orchestrated, executed at machine speed. At Tier 3, humans are still essential, but their role shifts. They're not in the workflow loop for routine operations. They step in for strategic decisions that require organizational judgment, for major exceptions that fall outside the agent's policy envelope, and for situations where the stakes are high enough that human accountability is explicitly required. This shift in human role, from executor to exception handler and strategic director, is what Tier 3 organizations are building toward. But it takes time, data, trust, and governance maturity to earn. Organizations that rush to Tier 3 without the foundation of Tiers 1 and 2 inevitably create systems they cannot trust, audit, or control. Before we close, let's crystallize the design principles that separate successful agentic deployments from failed ones. These are patterns distilled from real enterprise deployments, including the painful lessons organizations have learned by ignoring them. Principle 1. Start with one clear, bounded use case. The most common failure mode in agentic AI is scope creep at the design stage. Organizations want to build a general-purpose enterprise agent that handles everything. What they build is a system that handles nothing reliably. Pick one workflow, define it completely, make it work well. The lessons from that first deployment will be worth more than any amount of planning for a broad system you haven't built yet. Principle 2. Design your agents like new digital roles. An agent should have a clear job description, its domain of responsibility, its authority, its success metrics, the escalation paths it follows. If you cannot write a one-paragraph role description for your agent the way you'd write a job description for a human hire, it's not well designed. The more ambiguous the agent's role, the more unpredictable its behavior. Principle 3. Governance is not optional and not an afterthought. Least privilege access, policy enforcement, audit trails, observability, these need to be designed in from day one, not bolted on after you've already deployed a system that's taken actions you can't explain or roll back. Principle 4. Measure what matters. Define success metrics before deployment. Task completion rate, escalation rate, latency, error rate, user satisfaction. Monitor them continuously. Agents that cannot be measured cannot be improved. And perhaps the most important principle, treat adoption as an organizational challenge, not a technical one. The technology is ready. Whether your organization is ready to trust it, govern it, and integrate it into how people work, that's the harder problem. Invest in change management, training, and stakeholder communication with the same seriousness you invest in the technical architecture. You've now completed the blueprint for Agentic AI. In session 4.2, we'll go one level deeper. How do agents actually connect to your data and systems without requiring custom integration code for every new capability? The answer is the Model Context Protocol, the universal adapter that's changing how agentic systems are built. I'll see you there.